Hello and welcome everybody. Today in geometry we will look at angles that are formed by secants and tangent and how to solve for them when you see them inside a circle. So previously to this one we have the following setup right here where I solve for this as a sample, I guess, problem that you could possibly run into. And it turns out that this right here is actually a theorem that is in this section. So we kind of, went ahead and did a little bit, just went ahead a little bit, I suppose. So the theorem that I proved was the following over here underneath, where if you have an angle that is going to create two arcs where intercepts are, to be a little bit more specifically, where the angle is on the outside like so, where we call that x, and then it turns out that you have an intercept arc right here, a, and we have an intercept arc b over here, then the conclusion is that there is a relationship between those three angles, and the relationship is that x is supposed to be equal to 1/2 the difference between the two angles then, the bigger one minus the smaller one. The way that we proved it, if you remember, but if you don't remember, we can go ahead and take a quick look, is by using inscribed angle. So what we did was we said that we are going to take one point over here and then another point over here and then draw a chord inside the triangle. And as a result, being using the inscribed angle theorem, then that means that this angle over here is going to be a over 2. And then similarly, on the opposite side over here, because this is going to be arc with b, then that means that the inscribed angle on the other side, that's going to be b over 2. And so as a result, by looking at it through the exterior angle theorem, then we can say that a over 2, which is the exterior angle, is equal to the sum of its remote interior. So x plus b over 2. And then finally, we just go ahead and use some subtraction, and we get to our conclusion then. So it turns out that if we have scenarios that are similar to this, this equation or this formula also works out too. And so here's what I mean by that. The scenario that we looked at previously right here, this is what is known as a secant because you have two secant lines that are formed in this case in order to get those arcs and also the angle that we have. Now, in the cases below, where you have a tangent, meaning you have two tangent line, and then you form an angle and you still have two intercept arcs, or if you have, like, say, maybe just a secant and a tangent right here, it turns out that all these three cases actually works the same way. That is to say, according to the picture, x is still going to be equal to half of the difference between the two inscribed arcs. So here on the left hand side, let's go ahead and prove that with tangent and tangent, and the secant and secant, we're going to go ahead and leave that for, like, say, a homework assignment then. So for this one, the way we're going to do it is we're going to go ahead and create a line segment, or actually I guess in this case a chord to be a little bit more specific, between the 2 point of tangency. Okay, we're going to go ahead and create a chord according to that then. Now, in there you can see that we have a triangle, and that triangle, as much as I like to say that it is an isosceles triangle, it is unfortunately not. So we got to be very, very careful about it. But the one thing that we did prove about this from last time is that there are some angles in here that you can actually solve for. And one of them is going to be this guy over here. This is an angle that is formed by the secant tangent. According to the last section, this angle is supposed to be half of the measurement of the arc that you see inside that's inscribed. So that means that it is equal to b over 2. Okay, so that is one part then. Now, if you look at the other side, well, I guess it is going to be a congruent triangle in this, sorry, not congruent triangle, but rather it is going to be an isosceles triangle, because on the other side over here, using the same idea, because you have a secant tangent, then that means that you have b over 2 as well. So I guess I was wrong in that case. But anyhow, now what I want to do is I want to still find some relationship between all of these guys. So one that I definitely see is the following. I can see that b over 2 and then plus b over 2 plus x is equal to 180 degrees. So the question is then, well, how do we implement a into all of this? Well, A, if you can look at it a little bit closely, it is actually related to B because remember, both of those points are points of tangency. The whole arc of A is actually going to be the major arc to the minor arc of B. So what I'm trying to say is that A plus B is equal to 360 degrees. Okay, A plus B is equal to 360 degrees. So what I need to do is I need to kind of like take these two equations and kind of combine it together so you can see how to relate all of them then. So here, what I'll do is I'll take this equation over here that we just came up with, and I'm going to go ahead and solve for B over 2 so I can substitute it into the other equation. So B is equal to 360 minus A, and then that means that B over 2 is equal to 180 minus A divided by 2. And I'm going to go ahead and take this guy right here and substitute it into this equation over here as one of them, but not both of them because I want something that has both A, B, and X in their equation. So put it all together, we have now 180 minus A divided by 2, and then plus B divided by 2, and then plus X is equal to 180 degrees. Cancel out the 180 from both sides, and then I'm going to go ahead and leave X on the left while putting everything on the right. So now you can see A over 2 minus B over 2 is equal to X, which then leads into my conclusion of half of the difference between the two intercept arcs then. Okay. Now for the last one, for the secant tangent, as I mentioned last time, or actually just earlier, just now, I'm going to go ahead and leave that as a homework assignment. But to give you a hint as to like how to start with this, maybe what we can do is we can create a chord just like earlier between two of those points then. Okay. Or if you want, you can create the chord onto the other side and see how that actually works out. So, leave it to you to kind of discover a little bit. All right, so in conclusion, all of this is actually one single theorem. And the theorem itself, which is 710 right here, says that the measurement of an angle formed by either two secants, two tangents, or a secant and a tangent is half the difference between the two intercepts arc. And so that is going to be, I guess, the entire theorem then for everything that's over here then, okay? All right, now let's go ahead and use that as a numerical example so you can see how this actually works out. Let's say that I have one of those scenarios, one of those cases where you have, in this case, a tangent and a tangent, and I want to solve for the measurement of angle x, knowing that that exterior angle over here outside the circle is equal to 58. And so let me go ahead and clean that up a little bit because I think I erased it a little bit too much, okay? But there we go. Let me go ahead and write in the 58 once again. Well, there's not much to work with over here in this case, so we have a little bit of problem. Now, according to what we said earlier, we know one of the arcs, which in this case is going to be x, is what I'm trying to solve for. But then, according to what we said earlier too, we are going to need this guy over here, okay? Now, the theorem that we just worked on, we said that the relationship between these two is that if one of them is x, then the other one is the major arc of it. So that means it's going to be 360 minus x. And as soon as you write that right there, then we are pretty much good to go because now we can say the following. Using the theorem that we just came up with, we're going to say that x is going to be, not x, but angle, the measurement of 58, the angle on the outside, is equal to half the measurement of the difference between the two angles. So that means it's going to be 360 minus x. And then we have minus x for the other one. So you see this is the first angle and then this is the other angle. Now, if you're wondering, okay, which one do I set as x? Which one do I set as 360 minus x? It actually, well, according to the picture, 360 minus x is the bigger one. So that's why you're going to take that minus the other one. But if it's a case where you kind of messed up and you did the smaller one minus the bigger one, what will happen is that your answer will come out to be just the negative of it. So then that means you just have to multiply by negative and you'll still get the same answer. But anyhow, let's go ahead and clean this up. Multiply 2 to both sides, you get 116 is equal to 360 minus 2x then. So we're going to go ahead and subtract and then add to both sides. So 2x is on the left. And on the right side, that is going to be 360 minus 116. So that's equal to a 4, and then a 4, and then it's going to be equal to a 2. So then that means the measurement of x is equal to divide by 2. which looks like it's going to give you 122 degrees then. So there you go. That's how we're going to be able to solve for x then. Okay. All right, so now for this last one right here, for this last theorem, this one, we actually kind of have to, we're going to derive the theorem a little bit differently because we're going to use numerical values just to see how this actually works out. What I want to do in here is I want to solve for the measurement of angle x that's formed by two chords where we're given the measurement of the intercept arcs then. So one of them is 60, the other one is going to be 24. So here, let's go ahead and introduce another chord, so then that way you can see how this is going to be derived then. So the chord that I'm going to create is going to be this guy that's over here. So when we create that chord, knowing that because this measurement of the arc is equal to 24, then therefore the measurement of this inscribed angle is going to be half of that, which is going to be equal to 12. And similarly, if I go over here, right, that is going to be an inscribed arc that is according to this angle right here. So that means that's equal to 30 degrees. Looking at the two that we just formed, these two angles that I just found, and then looking at where it's located with x right there, you'll notice that x is supposed to be equal to the exterior angle of those two remote interior. So that means x is equal to 1/2, actually not 1/2, I'm sorry. That's going to be equal to 30 and then plus 12 degrees. Now, in comparison to the numerical values at the very beginning, that 30 is because it's 1/2 of the other angle. And then that 12 is because it's 1/2 of the other measurement of the arc. So now you can kind of see where I'm trying to come up with kind of like a formula. So then that way we can actually conclude how to solve for it every single time. So in conclusion, for this theorem right here, the solution is that if I have a measurement of angle x, which is going to be, again, an angle that is created by the intersection between two arcs, two chords, that x is going to be equal to the average of the measurements of the two arcs that you see over there. So that is to say that x is equal to 1/2 of not a minus b, but rather a plus b in this case then, okay? And again, the way that we proved it was we drew a line segment to create a chord over here, saying that this is going to be equal to b over 2 because an inscribed angle. This is going to be equal to a over 2 because it's going to be an inscribed angle as well. And then x is the remote exterior angle, so therefore x is equal to the sum of those two. So a over 2 plus b over 2, and there you can see now it leads into this conclusion then. All right, well, there you go. Thank you so much for watching. I will see you guys next time then. Have a good one. Goodbye.